2.6. The book calls this combining functions. I would like to call it the algebra of functions. And function composition. If I'm given f and g, given two functions, and if I say to you, create a new function called f of x, f plus g of x, and then I'll ask you, find the function f minus g of x, and then a function f g of x, and then f over g of x. With these given functions, find these four functions. Are the names self-explanatory? Do they tell you exactly what to do with these two functions? Yes? Okay, what does the first one? What will you do to determine the first one? Yes. What do I write? That's it. What about this? Awesome. Self-explanatory, right? This one? And the last one? However, this one has a comma and an if, which I did not have in the other ones. Not x.
G of x.
Correct. Is that clear? Perfect. This is what we call algebra of functions. That's what it is. Before we look at an example, I would like to discuss function composition. So there is a fifth way of creating functions from two given functions, and that is function composition. Before we talk about that, however, I'd like to mention one thing about these. And let me give an example. So let's say I have a function that is this. And I have a function that is, so this is my f, and that's its graph, and let's say g is this. 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 5, and this is 10, and that's my g. And let's suppose I ask you, find f minus g of 9. What would you say? You will say it equals awesome. Good. Perfect. How much is f of 9? Right. Which means I cannot create this function at 9. The function, the difference of two functions at 9 does not exist. What function can I create for these two functions, using these two functions? Can I create the sum?
Yes.
What will I plug in? Of course, they don't have a common domain. The concept of common domain. If there is no common domain, I cannot add, subtract, or divide, or multiply. So if functions don't have a common domain, I cannot create those four. So note, no common domain, comma, no addition, subtraction, multiplication, division of functions. Which is not the case for the function composition, however. If they don't overlap, if the two domains do not overlap, I can create them. Useless. They don't exist at the same time. So how can I add them if they don't exist for the same x value? So now the function composition does not require common domain. There is no common domain for function composition. Function composition works totally differently. So let's say we have 3 bubbles. And let's say I have here x. Let's say I decide to apply to x function g. When I apply to x function g, what do I get? Awesome. This is a number. And let's suppose I would like to apply to g of x another function called f. This is going to be a number, right? So I apply f to this number. What do I get? Awesome. That's all I needed. Perfect. So I know now what can go wrong here. What can go wrong? That f and g don't have a common domain. Not even a little piece. Not even nothing. Let's see what can go wrong here. So this is the definition of function composition. F of g of x. The notation is f, a little circle, empty circle, g in parentheses, and x. How do I read this? F comp g. Notice that I applied g first to x. That's why g is the closest to x. And then f is outside. And I can create the vice versa. G comp f. I can create g comp g. I can create f comp f. And I can go on forever. But what can go wrong here? Can anyone identify this set for g? What does this set represent for g? Where we pick values of x for a function, the set is called. We used it several times today. Very good. Now, what is this set for g? Very good. It's where the values of y or the function. Good. Perfect. Thank you. What about this same set for f? Very good. I'm going to put f here, domain for f, and I'm going to put range for g here so it's clear. So then what could go wrong? Here's what can go wrong. I get here a number that I cannot apply f to, and I will never be able to get here. So imagine I apply g to 0 and I get 5, but f is undefined at 5. So I cannot apply it. I cannot apply f to 5, so I can't get here. So the problem here is different for the function composition. If, quote unquote, the range of g and the domain of f do not work well together, then the function doesn't exist for those values. Okay, so let's look at an example of algebra functions, function composition. On page 197, I would like to start with let's say 26. No, I want to start with a graph. So 26 is giving us a function. So I want to choose from here. Okay. So I want to find g of f of 0. What do I have to find first?
F of 0.
Awesome. So f is in red. How much is f of 0? 0. F of 0 is 0. So then I have to find g of 0. So how much is g of 0? G is in blue. Exactly. So the answer for 28 will be 3. Okay, let's do one more. Let's choose another. 32. So let's find f of 4. I have to find f of 4 first. F is in red. So what is f of 4? 2. And then I have to find f of 2. How much is f of 2? Negative 2.
So that's it.
That's it. So now let's say we are given...
Okay. So the answer -2.
Yes. F of 4 is f of 4. F of 4 was 2. And f of 2 is negative 2. Let me write it. Maybe if you see it, it's better. So f of 4 is f of 4. This is 2. So f of 2 equals negative 2. Better? Okay. Let's look at two functions now and determine the function composition and the algebra functions. So let's say number 8 on 196. So we have f of x equals the square root of 9 minus x squared, and g of x is the square root of x squared minus 4. We're asked to find the sum, difference, product, blah, blah, blah. Let's choose one, but I want to find the common domain first, because I don't even know whether they exist. So how do I determine, oh, yeah, I'm sorry. Paul, say it again.
Oh. I'm following it.
Okay, so how do I determine the domain of f? What do I have to write in order to find the domain of f? So domain of f, what do I have to write? We had the domain of a square root function last time. We talked about the domain when we graphed the square root today again. So what do I have to write? Please dictate and I will write it.
X has to be greater than.
No.
9 minus x squared.
Ah, totally different story. I completely agree. 9 minus x squared has to be greater than or equal to 0. Perfect. Very good. Remember, it has to be in descending order. So let's put it in descending order, multiplying after that both sides by -1. Multiply both sides by -1 and switch the symbol. And I need to factor it. How do I factor this? Very good. Same thing. I'll use a chart. X plus 3, x minus 3, and the product. Negative infinity to infinity. What will go at the top? Which numbers go to the top? Very good. Good. And 0 here, 0 here, 0 here, 0 here. And then what will be the sign in all these, in the first two rows? They are linear functions with a positive slope. So the sign will be the same, meaning from very good to positive. Awesome. Two negatives on the first. One negative and no negatives. What sign do I want to pick? So domain for f is, very good, awesome. Now I want to find the domain of G. How do I find the domain of G? Yes, so let's solve that. Indeed, I have to write x squared minus 4 greater than or equal to 0. In the same way, with the chart, I would like to determine the domain. Let's determine the domain. And please tell me what you get. I'm sorry? I'm sorry? X squared minus 4. What do we get? So what would be the domain? Did we use the chart? Yes?
-3 and -2 union 2.
Very good. Completely agree with that. Now we have to find whether there is a common domain or not. Is there a common domain? If there is, then we can create. So indeed, -∞, -2, union 2 to infinity. So that's the domain of G. Do we all agree with that? Yes? Using the chart, you have 2 and -2. You will still get the same thing, positive, negative, positive, but this time you want positive. So that's why you have to pick the outside. So is there a common domain?
Yes.
Between -3 and -2, union 2 and 3. So let's create one function and then we'll stop. Which function would you like to create? Let's say the difference. So f minus g of x will be the square root. I should write it. I don't want you to get into the habit of just copying it. So I would write this at all times and then copy it. So I will write the square root of 9 minus x squared minus the square root of x squared minus 4, because we can't do anything to it anyway. And that will be the end of it. So on Monday, we will finish chapter 2 and we will review for the test. Okay, we have one more section to go, and we do have